Before getting into the various types of anemia, we need to understand the RBC indices. RBC is your red blood cell and indices is nothing but the plural of index. So these refer to the various features related to RBC. For example, the total volume of RBC present in your blood, or the total number of RBC present in your blood, or the concentration of hemoglobin present in your blood, or more specifically for a single RBC, the volume of single RBC, the amount of hemoglobin contained in that single RBC, or the concentration of hemoglobin contained in that single RBC. So you need to know about all these features. Why? Because once I get into the various types of anemia and start explaining the features of this anemia, also once I start comparing the features of various types of anemia, I'm going to use these RBC indices. So these RBC indices are important in order to understand the various features of an anemia and to compare the features of one anemia with another anemia. So these terms are going to be frequently repeated throughout this video. So I'm going to make the concept clear cut now itself, understand everything related to RBC indices. There are altogether 6 indices that you need to know. 1, 2, 3, 4, 5, 6. First is packed cell volume, which is also called hematocrit. Second is red cell count, which I'll be referring as RCC. Third is hemoglobin concentration. Fourth is mean corpuscular volume for one RBC, mean corpuscular hemoglobin of one RBC, mean corpuscular hemoglobin concentration of one RBC. Now let's look at all of them one by one. First, packed cell volume, PCV, which is also called hematocrit. What I do is take a test tube. This test tube is filled with 100 ml of blood which I have drawn from a healthy individual. To this 100 ml of blood, I add an anticoagulant. Why? In order to prevent coagulation of blood from occurring. Then I put this test tube in a centrifuging machine. In the centrifuging machine, the test tube, it spins round and round and round, and due to the centrifugal force, the heavier particles of the blood, they settle down, while the lighter portion of the blood, they float on top of the heavier particle. Simple class 10 plus 2 concept. Alright, so once centrifugation has occurred, in this 100 ml of blood, what happens is that the portion of the blood that is heavy, which is obviously the cells, they settle down, and the portion of the blood that is light, which is obviously the plasma, it floats on top of the cell. The plasma, it composes 55% of the blood. The cells, they compose 45% of the blood. The packed cell volume is the volume that is formed by these cells that are packed at the bottom of the test tube. So these cells, they form the packed cell volume. And as you can see, 45% of the complete volume of the blood is formed by the packed cells. So the packed cell volume is going to be 45% of the total volume of the blood. In this particular experiment, I have taken or I have drawn 100 ml of blood. So out of this 100 ml of blood, 55% or 55 ml is plasma, and 45% or 45 ml is the volume that is formed by the cells packed together, the packed cell volume. Okay, now this is the true definition or the mathematical definition. Packed cell volume is the volume of RBCs packed together per unit volume of blood. So you have your volume of blood. This is the volume of blood. Out of this total volume of blood, how much volume is formed by RBCs that are packed together? In this case, we have taken 100 ml of blood, and the amount of the volume of RBCs packed together is 45% of 100 ml, which is 45 ml. So it comes out to be 0.45. So the packed cell volume in a normal individual is 0.45. What does this mean? Okay, so if we take 1 ml of blood, 45% of 1 ml, which is 0.45 ml, is going to be composed of red blood cells. If we take 1 liter of blood, 45% of 1 liter, which is 0.45 liter or 450 ml, is going to be composed of red blood cells. So if packed cell volume is 0.30 milliliter per milliliter, what does this mean? It means that for every 1 ml of blood, we have 0.30 milliliter of red blood cells. Got it? One last time. What is packed cell volume? Packed cell volume is the volume of red blood cells packed together per unit volume of blood that we have taken. So let's say if we have taken 100 ml of blood, then in a normal blood, out of 100 ml, 45% or 45 ml of this 100 ml is going to be the volume of red blood cells. If we have taken 1 ml of blood, 45%, that is 0.45 ml, is going to be red blood cells. If we have taken 1 liter of blood, then 45%, that is 0.45 liter or 450 milliliter, is going to be the volume of red blood cell. And what is that? That's your packed cell volume. Whew. Okay, second is red cell count. Nothing but the total number of red blood cells present in unit volume of blood. So we take the total number of red blood cell, we divide it by total volume of blood, and then we get the red cell count. In a normal person, 1 ml of blood contains 0.45 ml of packed cell volume. How do we know that? We know that from this concept right here. And this same 1 ml of blood also contains 5 million red blood cells. So let's say I have taken a test tube, and this test tube right here contains 1 ml of blood. In this 1 ml of blood, if you were somehow able to count individual RBCs one by one, you'd find that there are altogether 5 million RBCs. And if you are somehow able to measure the volume of all those RBCs, you'd find that they compose 0.45 ml of the blood. So that means 0.45 ml of this blood contains 5 million of RBCs. Okay. Next up, hemoglobin concentration. Simple thing, you know how to find concentration. Take the amount, divide it by the volume. So in order to find hemoglobin concentration, you take the total amount of hemoglobin and divide it by the volume of the blood that you have taken. So for example, if you have taken 100 ml of blood, in this 100 ml of blood, you are going to find X gram of hemoglobin, right? Then the concentration of hemoglobin is going to be X gram per 100 milliliter of blood. Now, the lower limits of the hemoglobin concentration for different age and gender are given right here. From this, I also want to say that the hemoglobin concentration present in the blood of an individual is dependent on two things: the age of the person and the gender of the person. So let's look at the hemoglobin concentration of different ages and genders. In case of newborn, be it male or female, the concentration of hemoglobin is 15 milligram per 100 ml of blood. However, in adult male, 13 gram per 100 milliliter of blood. Adult female, it is less, 11.5 gram per 100 milliliter of blood. So let's say you draw blood from a person, you perform investigation on it and find out that the hemoglobin concentration in the blood of the person that you have, the blood that you have drawn, is 12 gram per 100 ml of blood. So the hemoglobin concentration is 12 gram per 100 ml of blood. Now, is the person anemic or not? Before that, in anemia, the concentration of hemoglobin in the blood is less than the lower limit. So there is a certain range of hemoglobin concentration, right? From this much to this much, from lower limit to higher limit. If the hemoglobin concentration in the blood of the person is less than the lower limit, then obviously the person is anemic. And what I have here are the lower limits in different ages and gender. Okay, I said that the hemoglobin concentration of the blood that I have just drawn is 12 gram per 100 ml. So can you say whether the person is anemic or not? No, you can't. The reason being the lower limit differs as per age and gender. So you have taken 12 gram per 100 ml, right? For adult male, 12 is less than 13. So adult male is anemic. It is 12 is less than the lower limit. In adult female, 12 is greater than 11.5. That is, it is more than the lower limit. So the adult female is not anemic. In newborn, 12 is less than 15, or the given value is less than the lower limit in newborn. So the newborn is anemic. Okay. Now that we have seen three different indices, packed cell volume, the volume of RBCs packed together per unit volume of blood, red cell count, total number of RBCs per unit volume of blood, and hemoglobin concentration, amount of hemoglobin present per unit volume of blood. Using these three different indices, we are going to find out the rest of the indices that are for single RBCs. These three indices were for your certain sample of blood, but now we are going to look at a single RBC from that sample of blood. First, mean corpuscular volume. Simple. It is the mean volume of a single RBC. How will you find mean volume of a single RBC? Take the total volume divided by the total number of RBC. Done. So you have the total volume, which is packed cell volume, divided by the total number of RBC, which is red cell count. So let's say if I take 1 ml of blood, 1 ml of blood, this 1 ml of blood is going to contain 0.45 ml of RBC and 5 million numbers of RBC. So divide 0.45 ml by 5 million. You are going to get 90 femtoliter. So 90 femtoliter is the mean corpuscular volume of red blood cell. That is, if you take a red blood cell from your body out and look at the volume, find out the volume of this red blood cell, it is most likely going to be at the periphery of 90 femtoliter. Got it? Okay. So on the basis of volume of the red blood cell, they are of three types. Normocytic, cytic refers to, remember, cytic refers to size. Normo means normal. Microcytic, cytic means size, micro means smaller than normal. Macrocytic, cytic means size, macro means larger than normal. So normocytic RBC have mean corpuscular volume of 90 plus minus 10 femtoliter. That is from 80 to 100 femtoliter. But then if the volume of the RBC is less than 80 femtoliter, it is smaller than normal, it is microcytic. But if the volume of the RBC is greater than 100 femtoliter, it is larger than normal, it is macrocytic. Next, mean corpuscular hemoglobin. Amount of hemoglobin, the mean amount of hemoglobin present in single RBC. So simple, take the total amount of hemoglobin divided by the total number of RBC. You are going to get mean amount of hemoglobin present in one RBC. Total hemoglobin by total RBC. So let's say I draw 100 ml of blood. This 100 ml of blood contains 15 gram of hemoglobin and 1 ml of blood contains 5 million RBCs. 100 ml contains 5 million times 100 RBCs. So you divide 15 gram by 5 million times 100 RBCs. You are going to get 30 picogram. So the average amount of hemoglobin contained in a single RBC is 30 picogram. Finally, mean corpuscular hemoglobin concentration. This is the concentration of hemoglobin, not the amount. The amount is mean corpuscular hemoglobin. So if you take out one RBC, it is going to most likely going to contain, if it is normal, 30 picogram of hemoglobin. This is mean corpuscular hemoglobin concentration. So the concentration of hemoglobin, that is amount of hemoglobin per unit volume of RBC. Okay. How do you do that? So you are finding concentration. What do? You take the mean corpuscular hemoglobin, that is in one single RBC. You take out one single RBC, the amount of hemoglobin present in this one single RBC divided by the volume of that one single RBC. Obviously, you are going to get the amount of hemoglobin present in per unit volume of that RBC, right? Array, you take out one RBC, you find out the total total amount of hemoglobin present in that RBC. You find the total volume of that RBC. You divide the total amount of hemoglobin by the total volume. You are going to get hemoglobin in unit volume of that RBC, and that is your mean corpuscular hemoglobin concentration. In other words, you can say take out total amount of hemoglobin in blood divided by the total volume of red blood cell. So in unit volume of red blood cell, how much hemoglobin is there, you are going to find it, right? Okay, so let's say you have taken 100 ml of blood. 100 ml of blood contains 15 gram of hemoglobin, and it also contains 45 ml, 45%, which is 45 ml of volume of red blood cells. So you divide 15 gram by 45 ml. So you are going to find in unit volume of red blood cell how much hemoglobin is there. That is hemoglobin concentration, and it comes out to be in percentage 33%. Okay, on the basis of hemoglobin concentration of single RBC, there are three types. 1, 2, 3. Normochromic. Chromic refers to color. Remember that color. Normal. Hypochromic, hypo less, chromic color, less colored. Hyperchromic, hyper more, chromic color, so more colored. If you look at a normochromic red blood cell, which is a normally colored red blood cell, you will find out that it is peripherally red, right? RBC, a typical RBC, here's your typical RBC, it is peripherally red. The reason being the RBC is not completely filled with hemoglobin. So here's your RBC, it is not completely filled with hemoglobin. The hemoglobin is present at the periphery of the RBC. So the hemoglobin is present at the periphery of the RBC. Centrally it is pale. So we call it central pellar and peripheral red. What do we have here? We have the peripheral red and the central pellar. Okay, first things first. In a normochromic RBC, MCHC is normal, 33%. The peripheral red is 2/3 and the central pellar is 1/3. So 33% of the hemoglobin present in this cell forms 2/3 of the peripheral red of the cell. Let's say the concentration, that is in per unit volume of the same RBC, the amount of hemoglobin is less. Here in per unit volume, there was certain concentration C. Now in this per unit volume, in this per unit volume of RBC, the amount of hemoglobin was, let's say, A. In this per unit volume of RBC, the amount of hemoglobin A is less as compared to this. There is less hemoglobin for the same volume, less hemoglobin. That means less concentration. If there is less concentration, MCHC is less than 33%. Obviously, the peripheral red is going to be thinner because there is less hemoglobin for the same volume. It is going to be less than 2/3, and the central pellar, it is going to be larger. That is, it is going to be greater than 1/3. Similarly, in hyperchromic, there is more hemoglobin for the same volume, more concentration of hemoglobin. So MCHC is going to be more than 33%. The peripheral red is going to be more than 2/3, and the central pellar is going to decrease, and it is going to be less than 1/3. Based on these various features of RBCs that we saw just now, we have three major types of RBC that we are going to find in different types of anemia. Let's look at them. First is microcytic hypochromic. Micro, small cytic size. So the size is smaller than your normal size. The size of the RBC is less than 80 femtoliter. Hypo, less chromic color. So MCHC is less than 33%. Normocytic, normal sized. So the size of the RBC is normal, 80 to 100 femtoliter. Normochromic, normal colored, that is the MCHC or the hemoglobin concentration in a single RBC, it is going to be 33%, with peripheral red, which is 2/3, and the central pellar, which is 1/3. Macrocytic normochromic. Macro, large cytic size is going to be larger, so it is going to be more than 100 femtoliter. Normochromic, normal colored, so MCHC is going to be, why did I write more than, it's supposed to be equal to, let me okay, so change that mistake. All right, MCHC is going to be 33%, that is, there is going to be peripheral 2/3 red and central 1/3 pallor. Here you go, here are all three types. So first you have microcytic hypochromic. Now here's the thing, let's say you draw blood, make a smear on a slide and observe it under a microscope. Now how will you find out whether the RBC is microcytic, normocytic or macrocytic? You can't, it's really difficult, or I don't even know how you are supposed to measure the volume of single RBC. Instead, what technicians do is that they compare the volume of single RBC, or the size. They compare the size of single RBC with small lymphocyte. This in purple is the small lymphocyte and these are your RBCs. So what they do is compare the size of RBC with the size of small lymphocyte. So lymphocytes and RBCs, they have comparable size. So if the size of the RBC is comparable to that of lymphocyte, it is normocytic, less microcytic, more macrocytic. Okay, that's for size. What about color? So in case of color, I said that there is peripheral 2/3 red, central 1/3 pallor. So the peripheral red is more than the central pallor. So you just observe whether or not the peripheral red is more than the central pallor. And you might say, what if it is really more than central pallor, that is more than 2/3? That is hypothetically, that is just hypothetical. It is not possible except for exceptions like spherocytosis, which I'll get into later on. But here's the concept. For size, compare with the lymphocyte. For color, see whether the peripheral red is more than the central pallor. So first, you have this RBC, obviously the size of which is less than the small lymphocyte. So it is microcytic. You can see that the peripheral red is less than the central pallor. So it is hypochromic. Second, the size is comparable to size of the small lymphocyte, normocytic. The peripheral red is more than the central pallor, normochromic. Third, the size is greater than lymphocyte, so it is macrocytic. The peripheral red, it is more than the central pallor, so normochromic.